This is the second video covering the first objectives for this unit and takes us to the four chambers of the heart. There are two upper and two lower. The atria are positioned superior and posterior in the body, so when viewing the heart still in the human body, most of what is seen are the lower chambers, the ventricles. Two auricles, ear-shaped structures, lie on top of each atrium. They function to collect blood and help the atria fill. The upper chambers receive blood from other parts of the body. The right and left atria fill the two ventricles, respectively. The ventricles then pump blood to other parts of the body. We'll look at that in a future video. The heart has four valves that are in place in crucial areas to ensure that there's no backflow of blood. The AV valves are found between the atria and the ventricles. The tricuspid, named so because of its three cusps or leafy-looking structures, lies between the right atrium and right ventricle. The bicuspid valve, also known as the mitral valve, is found between the left atrium and left ventricle. The stringy structures seen extending from the valves are the chordae tendineae. They tighten to ensure that the valves hold tightly closed. The semilunar valves are found in the lower heart chambers. They are the guardians of the passageway from the right ventricle to the pulmonary trunk and the left ventricle to the aorta. That brings us to the major blood vessels of the heart. First, let's start with definitions for arteries and veins. An artery is a blood vessel through which blood is leaving the heart. A vein is a blood vessel by which blood is returning to the heart. Blood being brought back from the body to enter the right atrium does so through the superior vena cava and the inferior vena cava. The heart, which also needs blood to function, returns blood through cardiac veins that converge to become the coronary sinus. On the right side, blood exits the right ventricle through the pulmonary valve into the pulmonary trunk, which quickly branches into two vessels, the right and left pulmonary arteries. Pulmonary arteries bring deoxygenated blood to the lungs. Another way to think of deoxygenated is oxygen poor. This is the reason that we cannot define arteries as carrying oxygenated blood. It is not the case. So is it with the veins that bring oxygenated blood back to the left side of the heart. The definition of a vein must be limited to the direction that the blood flows and not to the state of oxygen levels. The left and right pulmonary veins bring oxygen-rich blood from the lungs to the left side of the heart, specifically to the left atrium. Blood fills the left atrium and passes through the bicuspid valve to the left ventricle. Blood then is pumped from the left atrium through the aortic semilunar valve into the ascending aorta. To ascend means to move in an upward direction. The ascending aorta then curves, forming the aortic arch, which then continues downward to become the descending aorta. There are two parts to this, the thoracic in the chest and abdominal aorta, which gets its name once the descending aorta has passed through the space of the diaphragm. The fibrous skeleton of the heart plays a very important role. It is a network of collagenous and elastic fibers that provide structural support for the heart. If you dissected a heart, you would have seen part of the fibrous skeleton surrounding the great vessels coming off the heart. The fibrous skeleton helps to keep those vessels open. Another important purpose of this fibrous skeleton is that it acts as an insulator between the upper and lower heart chambers. It is important that the electrical current which causes contraction of heart muscle tissue occurs in the proper order. Atria first, then ventricles.